Chapter 6, a test review. First, if you want this review guide that I made, just text me and I'll send it to you. I'll email it to you. And then also, actually, yeah, this is gonna be kind of long, I think. But, I mean, we all wanted to get on the test. Basically, everything we learned about were angles. This side of the angle where it starts is the initial. Okay, we don't want to tap. Is the initial side, and then where it ends is the terminal side. So, angles that are coterminal end in the same spot. They might have a different journey to get there, but they terminate in the same spot. We learned about angles in degrees and radians, and these four are the four that are on the axes. So they're kind of important, and they help you figure out where the rest of your degrees or radians are. And then two conversion factors you need to remember are that 180 degrees equals pi radians, and 1 revolution will equal 2 pi radians. Those are just two little conversion factors. So if we wanted to know where 390 terminated, we would do 390 minus 360. That will give us 30 degrees. So 390 degrees is coterminal with 30 degrees. For 19 pi over 10, well, we would know that 20 pi over 10 is 2 pi. So 19 over 10 is almost 2 pi. So this one would terminate right about here. Okay, I'm drawing at a really weird angle, so please excuse. It'll terminate somewhere around there, almost making a full revolution. Then we did the unit circle, which we all know and love. Important ones are 0, 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. In radians, that's 0 radians, pi over 2, pi, 3 pi over 2. So, obviously you can see them all right now, and I guess you do have to memorize them, but one little hack to remember where things are, especially for the denominators, are the denominators over 6 are right here, over 4, over 3, and then there's the 2 there. So any quadrant, it's going to go 2, 3, 4, 6, 2, 3, 4, 6, 2, 3, 4, 6, 2, 3, 4, 6. And then another way I like to think about it is, say we're given 5 pi over 2. We have to figure out where that goes. Well, a denominator of 2 means a half, so we're going to do 5 halves. 5 halves of 1 pi. It's kind of confusing if you think about it that way, but you do 5 halves. 1 half, 2 half, 3, 4, 5. 5 pi over 2 will terminate on the positive y-axis. So just take some time to study this. And then, another thing is all the 45-degree angles end in the number 5. So everything else ends in a 0, but the 45-degree angles, 45, 135, 225, and 315 end in 5s. Might make it a little easier to visualize where you can see it. The next thing we did were some application things. So we did arc length, which is the length of a piece of the circumference. A length of the piece of the circumference. Okay, a piece is a fraction in the, equation for circumference is 2 pi r. So the formula for arc length in degrees is is going to be a fraction, 2 pi r. In radians, however, it's going to be theta r. For sector area, that's a piece of a pi, so a fraction of the full circle. The formula for the area of a circle is pi r squared, so we're going to have, that's embarrassing. Wait. we're going to have fraction pi r squared in radians, theta r squared over 2. The next thing we did was linear speed. So I don't really know what the difference is, if I'm being completely honest, so just pretend like I do. The equation for linear is going to be v over s over t. That's the sector length. And angular speed is going to be omega equals theta over t. T is time. There's one other way to write linear speed. So the equation for s, we just saw it's over here. S equals theta r. So, okay, we'll put theta r, we'll substitute in over t, which equals theta over t times r. Well, theta over t is omega times r. So another way to write linear speed is omega r. The next thing to do is unit circle. So on the unit circle, this is a circle that is on a coordinate plane. The radius is always 1. Every single one of these lines is 1 unit. So some important coordinates would include right here, 0 degrees, 360 degrees, 2 pi radians, 0 radians. This coordinate is going to be, 1 over 0 up. For 90 degrees, we're going 0 over 1 up. Over here, negative, that should be negative. Negative 1, 0 up. Over here, down, and 0. The next thing we did was those coordinates are kind of self-explanatory. For this, however, we're gonna have, this creates a triangle right here. This is 30 degrees. 30 degrees, 60 degrees, pretend that's a 90. That's actually straight. Okay, that's close enough. Well, when we figured out the trig in our notes, which I'm not gonna do it all right now, we found out that this side is root 3, over 2, and this side is 1/2. Therefore, our x is root 3 over 2, and our y is 1/2. Okay, we did the same thing for this triangle. We found out that this x side is root 2 over 2, and this side is also root 2 over 2. This triangle, this is 60 degrees, this is 90 degrees, so this has to be 30 degrees. Well, we just saw a triangle with those exact same side lengths, which means it's just a different perspective. So I'm going to draw this one. So this triangle, now our x is going to be 1/2, and our y will be root 3 over 2. And the rest of our coordinates are those exact same numbers, just positive or negative. So over here, all the x's are going to be negative, but all the y's will be positive. All the x's will be negatives, all the y's will be positives. All the x's will be positives, all the y's will be what am I trying to say? That should be positive. Okay, I'm gonna fix that later. The next thing we did was trig. So for this part, we know that sine, cosine, tangent is SOHCAHTOA. Sine is opposite over hypotenuse. Well, over here, this is our angle right here. of this like 30-degree triangle, if you're imagining it, well, the opposite would be this, which is the y value, or the x value. What? Okay, just joking, I'm confused. Ignore that. We know sine, the ratio for sine is y over r. For cosine, x over r. Tangent, y over x. Cosecant, r over y, r over x, x over y. But when we're on the unit circle, r equals 1. Y over 1 is the same thing as just y. X over r is the same thing as x. It's the same thing as 1 over y, 1 over x. But the thing is, those four underlined only apply to the unit circle. If we're off of the unit circle, r isn't 1, so you can't just get rid of the denominator. For example, 2 over 1. If your radius is 1, 2 over 1, that just equals 2. But if your radius is 3, 2 over 3, that's not the same thing as 2. So you'd have to make sure that your r stays 3. Another thing is, these functions are reciprocals, which there's more down at the bottom. Okay. This is like our quadrants, quadrant 1, 2, 3, 4. It's just to remember that your values are going to be positive, positive, negative, positive, negative, negative, positive, negative. Hopefully that makes sense. That's just a little helping hint to figure out your quadrants. If you ever see something that looks like this, pi is less than theta, which is less than 3 pi over 2. That means this, I mean, you could read it as that and try to figure it out, but it just means that theta is in between these two. So if we have a unit circle, pi is, oh, that's not a circle. Okay, there. Pi would be right here. 3 pi over 2 is down here. Our angle is in this quadrant, quadrant 3. Okay, so anytime you see the word, or well, 2 inequalities, it just means in between. I'm gonna do this really quick example problem. So the ratio for sine is y over r. Therefore, our y is 1 and our r is 3. We know that cosine is less than 0. Less than 0 means negative. Cosine means x over r. Well, we already know what r is, so that means x has to be negative because r can never be negative. Now, what quadrant are we in if we have a negative, comma, positive? Negative, comma, positive, quadrant 2. Now, we have everything but our x. To find that, we're going to do x squared plus y squared equals r squared. Well, we don't know x squared. Y is 1 and r is 3. So we know it's going to be x squared plus 1 equals 9, x equals 8, x squared equals 8. If we square root both sides, x equals square root 8, which equals 2 root 2. So your x is going to be negative 2 root 2. And then from there, you can use these functions to figure out your sine, cosine, tangent, all of your ratios. For this one, so tangent is y over x. So your y is 1 and your x is 2. This is saying that theta, your angle, is in between pi and 3 pi over 2. Well, if we get our unit circle, pretend it's a circle, here's pi, Here's 3 pi over 2. We're in quadrant 3. Wait, quadrant 3, our x's and our y's are negative. So x and y both have to be negative. The only reason it's positive is here is because negative divided by negative becomes a positive. Now you would do the same steps of this to find r, but I'm not going to do that. If you want this, you can work on that one yourself. Okay, I think this is the last page. Reciprocal identities. Anytime you see sine of theta, you can write it as 1 over cosine theta. So if it says sine of 18 degrees, that equals 1 over cosine of 18 degrees. Same for the rest of them, which you can read yourself. Our quotient identities are anytime you see tangent of theta, you can write it as sine over cosine. So if you see tangent of 18 degrees, that equals sine 18 over cosine 18. Same opposite with cotangent. Pythagorean identities. So this is the main one you need to remember, that sine squared theta equals cosine squared theta, which equals 1. By the way, the sine squared theta means you're squaring theta. So if theta is 3, this would sine squared 3 equals sine of 9. That's what the squared means. You can't square multiplication, you can't square addition, you can't square trigonometry. It just means you're squaring this number. This is just the math to figure out why it means 1, but if you can just remember that this is 1, you're golden. These are 2 extra ones that, the math, this is the same thing over the same thing, which equals 1. This is another way to write cotangent, and this is another way to write cosecant. So these are, 2 other identities. So the last thing I have is, these are just straight from the notes, which I have them down here if you want to do them on your own. But I'm just going to kind of explain as best as I can. So this is going to be tangent 20. Well, sine, that's supposed to be a degree sign. Sine over cosine, that's another way to write tangent of the same degree. And that will equal 0 because 3 minus 3 is 0. Tangent 20 minus tangent 20 is 0. The next one, okay? The first thing that sticks out to me is that it's squared. That means we're going to be using one of these instead of one of these. Well, sine squared, sine squared of pi over 12 plus, well, what's the reciprocal of secant? Cosine. Wait, we have an identity for that. This one. You see how those are similar? Just the theta is being replaced. This one equals 1. Sine of 30 degrees. First thing that sticks out to me is 30 degrees is an angle on the unit circle. 30 degrees. Sine, the ratio for sine is y over r. R is 1, so it's just y. For 30 degrees, y is 1/2. Sine of 390. Okay, 390 isn't on our unit circle, but it's coterminal with something. As on the very first page, 390 is coterminal with 30 degrees. We just did the sine of 30 degrees. Also 1/2. This one. Okay. Where will 370 terminate? I'm going to draw this one out. 10 degrees is about here, ish. Give or take. 370 degrees, well, all the way around is 360 plus another 10. Oh, they terminate in the same spot. Trig doesn't care about the journey, it cares about where it terminates. These angles are the same. Obviously 10 does not equal 370, but they end in the same spot. So essentially, this is theta, this is theta. We know that has a property 1. It equals 1. This, it's essentially the same thing. It's secant of 45. Oh, 405 terminates in the same spot as 45, cosine 45. Well, what's another way to write cosine 1 over secant? These cancel, your answer is 1. Over here. Okay. First we just want to try to condense this. Well, let's start with this half first. What's another way to write tangent squared? Sine squared 15 over cosine. Okay, just this half of the problem first. Whoa, just this half. Okay, I don't even care. Wow, those cancel, so we're left with just sine squared of 15 degrees. And we're gonna add that with cosine squared 15 degrees. That's one of our properties. It equals 1. The next one, sine of pi secant 15 squared. Well, okay, this one, you don't even need to go that far. This is all multiplication. The sine of pi is y. What's the y of pi? It's on this side. The y is 0. Anything times 0 is 0. Doesn't matter if that is, doesn't matter if that is, your answer is 0. This one, I'm going to draw it out. Okay, 20 degrees would be around here. 200 degrees. 200 degrees is 20 more than 180. So here's 180, we're going to go 20 degrees more. Wow. Okay, pretend that's a straight line. Wow, it looks like these two angles have the same reference angle. They're both 20 degrees out from their quadrant. This is 20. Oh, that should actually be here. 20 degrees, 200 degrees. Okay. Well, 20 and 200 aren't, neither of them are on the unit circle, so can't do anything with that. We do know that these coordinates will be positive, but these coordinates will be negative. We don't even need any numbers for this math because the tangent of 20, tangent is y over x, times cotangent of 200. Cotangent is x over y. These cancel. Whoa. These cancel. Your answer is 1. This is the same thing. Your stuff cancels. If you see it on the notes, your answer is also, this one will be, yep. Hopefully that makes sense. Okay, I kind of went kind of fast. I feel like I made some mistakes. So let me know if anything's wrong, and then let me know if you need any help.